Lesson 30, this is graphing functions. So there are several different ways that we can graph functions. We can put them in specific forms, such as y equals mx plus b. We can create a chart, a x and y chart, and we can plot those points and connect the dots. Okay, but there are a few things that we need to know about specific types of lines. If they're linear, in other words, they have a power of 1, then they're just a straight line. If they're nonlinear, and that means they have a curve somewhere in them, they tend to have higher powers, like x squared, or x to the third, or x to the fourth, or whatever. Okay, so when we're graphing those, keep that in mind. If it has a power of 1, it's going to be a straight line. If it has a different power, then it's going to end up being curved. So the first example, we're going to use tables to graph these, and we're going to use a graphing calculator. It's pretty neat to use this. So on example 1a, we take our graphing calculator, and what we just learned was hit the y equals button. It says type in y equals x. So y sub 1 equals, all we do is put in x. Graph that. Okay, and we can also have zoomed out if we needed to. But it graphs this line. And in order to graph it on our paper, all we have to do is follow a few sets of points. So in order to do this, I just want to create an x and y chart. I now know that it's linear because I can see it on my graph. So I'm going to graph the points y equals x in an x and y chart. Now you can do this vertically or you can do it horizontally. I don't really care which. I like to do them vertically because it looks better for me. Because if I do them straight down, I can see the coordinate pair. So I've now graphed it. I'm going to type in second graph, and it'll give me my table of values. Okay? My table of values, I just need 2 or 3 points to make a good table of values. I like to use -1, 0, and 1. I try to use 3 of them. So -1, 0, and 1. And then I just put my y values, which end up being -1, 0, and 1. Okay? And this one's really easy. We can make up those numbers by ourselves rather quickly. Okay, and then I just have to graph them. Remember that in our graphs, there are 2 things that we need to do. One, we need to follow the x-axis. That would be our horizontal axis first. So -1 will go -1 this way. Then y, that's following my vertical axis, which will bring me -1 this way. So I have a solid point right there at -1, 1. The next one's going to be at 0, 0, also called the origin. Next one's at 1, 1, so I'll go over 1 and up 1. And then all I have to do is connect those 3 points with a line. Because it was linear or had a power of just 1, this will be a straight line. Okay, keep in mind, when I say line, I mean it literally. Lines have arrows because they continue forever and ever and ever in both directions. Okay, any questions there? Okay, I'm going to use a different color for example B, but I'm going to use the same graph. Okay. On example B, it gives us y equals x squared. So again, we're going to take our calculator, press the y equals button, clear out the last equation, press x, and then put the 2 on it. So you have 2 options. You can press this x squared button that's down here. It's about midway on the left side. There's an x squared button. Or you can press raise to the power of 2. This little caret top is a raise button. So if we want to raise it to the power of 5, we can press raise 5. Okay? After I hit that, press my graph. You'll see some kind of shape that looks like this. Let's change our window again. We'll get that practice really quickly. As a default, we will normally set our window to minimums of -10, maximums of +10, and scales of 1. So -10 is my minimum, +10 is my maximum, scales of 1. -10 is my minimum, maximum is 10, scales of 1. Okay, that's just kind of my default go back to. Okay, it makes everything center in the graph, which looks really nice, and that's exactly what my stamp does that y'all guys can use, so it comes in handy. Anywho, you can see that since this was an x squared function, as in it is not linear, it has a curve. It has a minimum right down here. Okay, we need to find out where that minimum is. In other words, we need to figure out where it stops going down and starts coming back up. So I'm going to go to my table, over here to my table. I'm at my table, and I'm going to start looking for values of y. Okay, and notice that my values of y are big, and as I go down here, they bottom out at 0 and then start going back up again. Okay, so I see that what I'm going to call the vertex, this right here, the bottom piece is going to be called the vertex. I see that my vertex is at 0, 0. Okay, so what I want is something to the left of my vertex and something to the right of my vertex, so I know where to plot my points. So since my bottom piece, or the minimum, is at 0, 0, I can graph those points. Okay, I'm going to start an X and Y chart, X and Y. I only need 3 points, so again, I'm going to use negative 1, 0, and 1 since my vertex is at 0, 0. Negative 1, 1, positive 1, 1. Red for this. Okay, I'm going to plot the first point. Negative 1, comma 1 is right here. 0, 0 is again at the origin. And then 1, comma 1 is right there. Now, you have to keep in mind that this is also going forever and ever and ever. So I'm just going to connect it and try to make it look like my graph. It opens upwards, kind of big, right? So this is called a parabola. Not a parabola. It's not a type of snake. A parabola. Anything that's curved, you're going to need at least 3 points. You're going to need them where they curve. So it curves right here in the center at 0, 0. So I need to graph the point at its curve. Any questions there? You guys getting comfortable with that y equals function and the table function? It should help you a lot. Make your homework really quickly. Okay, example 2. Matching a table to a graph. So for example 2, you just need to look at the pictures that you have. Okay, so the first one, I want to look at these graphs. Okay, so looking at these graphs, I know that my slope is positive or negative in graph 1. It's positive, right? So since my graph is positive, my slope must be positive in my equation. Okay, looking at graph 2, positive or negative? Negative. It's going downhill. And graph 3, positive. So one of these is not like the other, right? It's graph 2. It's going to have a negative slope. It's going to be trending downward. So I'm going to look over here at my equations. I'm going to look and see which one of my slopes is negative. Which one of my slopes is negative? Table 1, 2, or 3? 3 is negative, right? Negative 1/2. Remember that slope is right in front of the x. Slope is right in front of the x. Okay? So 3 has a negative slope, so I know graph 2 and table 3 go together. That eliminates one of my possibilities already. Use that process of elimination. So table 3 and graph 2 go together because they are both negative. Now the other two are positive, right? So looking at table 1, what is my slope on table 1? Remember, slope is right in front of the x. 1 over 3. It's rise over run, right? So we rise 1, run 3, rise 1, run 3. I feel like I need to remind you guys of this because I think we're falling a little bit behind. Y'all aren't answering my questions. Okay, M is slope. It's just the thing in front of the x. Some people know it as rise over run. That's how I will refer to it. B is your y-intercept. It's where it crosses the y-axis. So if I was going to use this chart right here as an example, my y-intercept crosses my y-axis at 0, and my slope is 1 over 1, so it's 1. Okay? So there's my example. Going back over here, we notice that our slope is rise 1, run 3. So I'm going to see which one of my graphs, 1 or 3, match that criteria. So looking at graph 1, I'm going to start where it crosses the y-axis. Looks like somewhere near the origin, maybe. Huh, not really. That is not helpful. Okay, it looks like it crosses kind of at the origin right here. Not really. Huh, that is crazy. Okay, so it looks like it crosses at the origin. I'm going to see how much I rise before I hit another perfect spot. Yeah, I don't think they actually meant to do that. Anyways, let's just count it. It looks like they're counting by 2s. Okay, so I'm going to count by 2s as well. I don't like this graph at all. Let's just count by 1s. So we go rise 1, 2, 3, 4, 5, and over 1. Which slope has a slope of 5 over 1? Is it 1/3 x or is it 5x? It's table 2, right? So table 2 has a rise of 5 and a run of 1. So table 2 and graph 1 go together. Table 3 and graph 2 go together. What does that leave table 1 to go to? Graph 3. And I want you to look at graph 3 as well. It crosses right here. I go up 1, over 1, 2, 3, and it crosses another perfect axis point. Okay? So my slope also matches in that equation. So rise 1 over 3. All right, here's an interesting fact for you guys because I don't like the way that they did this. Notice that all these are counting by 2's. Okay, even if I counted by 2's like they did, I'd go up 2, over 2, 4, 6. So my rise was 2, right? My rise was 2, my run was 6, and when I reduce this, I get, again, 1/3. And 1/3 matches up here, okay? Matches my graph. So even if it is a difference in your coordinate, I mean your interval, you can still count the same. Because when you reduce it, it'll be the exact same answer. Okay, example 3. You have to keep this in mind. You need this. If you use note cards, you need to write it down in your note card. I highly suggest you all use note cards. Come in handy test time. Example 3. Matching the equation to a graph. I'm going to give you all guys a big hint. You wouldn't need to write these down as well. I told you that things that are curved tend to have something other than a 1 as their exponent. Things that are straight have a value of 1 or a magnitude of 1 power. Now this one is new. This makes that V shape. Okay, these are absolute value kind of functions. When it makes a V shape, okay, these are absolute value kind of functions. So in my notes, I would write down all 3 of these graphs. Say this has an exponent of something other than 1. This one has an exponent of just 1. And this one is an absolute value function. You're going to have to get used to seeing these different types of graphs. Okay? The easiest way to look at them is just to pick a point that they cross and then plug it in and see which one of them works. Okay? But you may notice something. They all cross the y-axis in the exact same spot. They all cross the y-axis up here at 3. Okay? They all cross there. So I wouldn't use that point. Wouldn't work for you very well. However, if I use this point, which is 10, 6, I could plug that into each of those equations and see which one works. As a default, I can plug these in to my calculator, right? So turn on your calculator. I'm going to show you how to do an absolute value function. So turn on, press your y equals, clear out what's in there. Okay, there's a button that says math. Okay, it's right below alpha. So hit that button. Tab over to number. It says num on top. This abs button isn't an instant miracle for a 6-pack, Levi. It is, however, absolute value. So go ahead and hit abs. We're going to put in x. So put in your alpha x. Close your parenthesis because that's all that's inside the absolute value is that x. Okay? And then it says plus 3. So plus 3. Then I can graph that. So I can check really quickly which graph matches what just by typing it into my calculator. We see that V shape, and I go, it's graph 3. It's really easy. Equation B matches graph 3. And I can do the same thing with the other ones. If I want to use the square root function, I can type in the square root function, clear out my y sub 1. Square root is, see where it says x squared? We just press second, x squared, and then there's our square root thing right there. So square root of x, close our parenthesis, plus 3. And again, we can just press graph and it does it for us. Okay, we notice that it has a slight curvature and it's bending outwards. That's graph 1. And the last one is one that we already did, so we can just type that in really quick. X plus 3. Make sure you clear out everything from the last graph. And you should see that graph right across. So you can double check everything that you do in your calculator. Questions? Okay. With that calculator, there's really no excuse to get those kinds of ones wrong, as long as you type them in. Okay, example 3 is done. Example 4. Identifying domain and range. We need to remember, domain is our x values. Our range is our y values. And in a graph, we're going to use example 4a. It gives us the square root of x plus 1. We notice that it starts right here. Okay, this is at 1. And then it goes up and it curves and it goes on forever to the right. Okay, so our x values are right here on this x-axis. So when I'm asking, where does our x value start? I'm going to pretend like I'm walking along the x-axis looking up and down saying, where do I see my line? I don't ever see it on the left, so there's nothing on the left that it follows. On my right, however, when I'm looking at it, I start seeing it immediately at the y-axis. So this is where x equals 0. So I start seeing it x equals 0. And then it's traveling along the x-axis. I see it. How long will I see the line on the right? Say forever. Good job. You will see it forever. So if I see it forever on the right, it's everything from 0 on, or better yet, x must be greater than 0, greater than or equal to 0. So as I write my domain, for example A on 4, my domain, and I want you to write it as a set, okay? My domain will be the set of numbers where x is greater than or equal to 0, because it starts at 0 and goes forever to the right. My range, however, starts at a different place. My range is my y values. So I'm looking specifically at where my y's start. I'm looking left and right as I travel along my y-axis. I don't see it, I don't see it, boom, I start to see it. It's again at 1, and as I travel up, I'm going to see it for how long? You say forever. Forever. Okay? I will see it forever on the right because this arrow tells me that it goes forever and ever and ever, and it continues to go up, so I'll always see it. So since it starts at 1 and goes on forever, it's going to be the set of numbers where y is equal to or greater than 1. And there's my range. Okay, that was for A. On B, it asked me to find the same thing. It says identify your domain and also identify your range. So again, I identify them as sets. It's the very first thing you should do is identify it as a set. So looking here at B, Levi, where's my minimum? It is that low number. Where's it at? Look at your book. What is the coordinate of my vertex? I named this my vertex. What is my coordinate there? My vertex is at -1? No. It's a point. What is the point, Sadie? Example B. Vertex. What is that point? Say it again. Coordinate points are represented as two pairs, like 1, 1, or 0, -2, right? My vertex is at 0, -2, right, Levi? So where's my vertex? Where's my vertex?
0, -2.
Okay. So my vertex is at 0, -2. Then I have a piece of information that I will need to use on my range. My range is my y value. So where do my y values start, Levi?
0, I don't know.
My y values start at -2. As we just stated, they start right here. As I travel up, how long do they go, Levi?
Forever.
They go on forever. So my y values start at -2 and go on forever. So I'm going to write that down. My range is y must be greater than or equal to -2. And then I close my set. My domain, those are my x values. Anytime you see a parabola, you're going to notice something. As I travel along my x-axis to the left, I will always see my line. As I travel along my x-axis on my right, I will always see my line. So if I always see my line, no matter which direction I travel, whether it's toward negative infinity or positive infinity, my options are all real numbers. Every single number known to man. All real numbers. So in order to represent all real numbers, I can write the words, all real numbers. I can write all, and then the symbol for real numbers, which is just a boldface R. And I can also write, I'm not going to go that far, it's a college level thing. So we'll just write all real numbers, okay? Any questions there? Okay. Our notes are ending right there.